Everybody, welcome back to our last session of the RIOT Summit. It will be session 4, which is open source operating system perspectives. And we have our first speaker, Lazar. Lazar is a computer scientist and a software engineer, previously working at FTN University of Novi Sad, Serbia. And right now he's working on some cool operating system projects at Huawei Dresden Research Center. And the floor is yours.
Thank you. Well, to start off with a question, how many of you have heard about OpenHarmony before this? Oh, so quite a lot. And how many of you actually know what it is? Okay. Just kidding. So basically, OpenHarmony is operating system project, which is operated by Open Atom Foundation. Open Atom Foundation is it's something like a Chinese version of Linux Foundation or Eclipse Foundation. So it's a foundation which fosters open source projects in China. So why is OpenHarmony there? Actually, it started Huawei. Huawei was using Android for its devices, and then it's started to need something else. So basically, extended Android was extended until it was no longer Android, right? So basically, it became something which is called Harmony OS. So just as Android has its open source version, AOSP, the open source project. So Harmony OS has its open source version, which is OpenHarmony, right? So now it serves as a base for Harmony OS. How? Well, it gets everything ready as an open source, and then just proprietary stuff is added and some tweaking, and it becomes Harmony OS. So that's about the relationship. So Harmony OS is currently operating system which is used in most of the Huawei consumer products. Okay, so why was Harmony OS? Why Harmony OS and conversely also OpenHarmony? There was a need for higher integration of devices. So the way it was done is that the concept of super device was conceived. That devices are connected seamlessly into one big device. So basically, you were able to just transfer your image from your phone to your TV screen. Well, you can do it already, right? You can just connect your mobile device to your screen and then transfer it. Yeah, but with this super device, this is seamless. So basically, you don't need to connect anything. You just need to connect it once, and everything else just works. And it's not just screen; it's there's a whole range of different kind of devices, like glasses, smart glasses, or smart watch, video games, health devices, and so on and so forth. So how does it work? It has something called DBus. It's a framework for connecting devices, and we will not get into too much details, but it's a kind of infrastructure which supports virtualizing devices, virtualizing peripherals, like distributed scheduling, so you can transfer your web browser from one device to another. And of course, data is distributed among the devices. So this is the technical architecture of OpenHarmony. We're not going to get to much details in it, but here we're just like to point out that OpenHarmony can have different kernels. So for some devices like laptops and mobile phones, Linux can be used as a kernel. For some other, where Linux is too cumbersome, there's RIOT OS, which is IoT operating system from Huawei, can be used. And of course, there is open space for other kernels to be used, which is where we come to the RIOT story. So to cover all these different scenarios, when you can include different kind of modules, you don't need the same kind of software for a laptop or mobile phone as you would need for a watch or I don't know microwave oven, right? So in order to accommodate that, there are you can do this manually, like you link the modules which you need, but there are already predefined 3 system types which you can choose when building. So basically, you can have a standard system, which most people would here have associated with the Harmony OS so far, like laptops, mobile phones. Small system, which would be like routers, IP cameras, smartwatches, and so on, and mini systems. Like home appliances, robots, and so on. The difference is mostly in size. Like standard system uses large CPU multi-core with more than 128 megabytes. I think this is the limit for Linux to run these days. It uses Linux as a kernel. And it has all sorts of bells and whistles which are required for these kind of devices to run. Small systems have less memory, but they still have a CPU with memory management unit with about 1 megabyte of memory, and it uses RIOT OS A version. Why A? Well, it uses Cortex A CPUs, right? It has more or less modules than standard system, but for really small systems, there is this mini system which has even less than power. So it uses MCUs, like microcontrollers, 128K of RAM, RIOT OS M version or Cortex M series, and everything else has been made lightweight to fit into this lighter amount of memory. Right? Okay, so we kind of thought about RIOT. So why did we think about RIOT? First of all, it's academically renowned, and it has it's flexible for experiments, something we can give our students to work with. It's open source, it's vendor neutral, it has a very good hardware and protocol support. It has a POSIX-like API, which is nice for newcomers to work with, and it's very small, it's very modular, and of course, last but not least, it's friendly iOS for IoT, right? So how can we achieve this kind of marriage between OpenHarmony and RIOT? Of course, it does not come without any difficulties. The most difficult challenges here is API compatibility. Like they have different system APIs. If I just go back to the technical architecture side, there is something called kernel abstraction layer, which is kind of a set of adaptation layer between OpenHarmony and the kernels. So the work has to be done on that. So life cycle mismatch. So basically, OpenHarmony has some expectations about life cycles of tasks, like thread can go to background to accommodate this power efficiency demands. Their build system or build systems are different. OpenHarmony uses a GN or Ninja, and while RIOT is based on Make, which is proved to be very well, not so easy to accommodate. Driver models are different. OpenHarmony uses something called HDF system, which requires a bit of work to adapt for RIOT. And of course, memory and task management models are different. But this for now, this is all proved to be not impossible to achieve. Right? So who's working on currently? So we use RIOT to work with OpenHarmony, for our students to work with OpenHarmony. So these are our students in alphabetical order, and they're supervised by Bojan, who you know, Yue, who's also here, and myself, of course. So, what are the projects that we are working on right now? So, main thing is to port OpenHarmony to RIOT. Currently, Diman is working on it. Porting RIOT OS to QEMU. Well, that's an interesting thing. I mean, RIOT supports really a lot of boards, but it did not support MPS to AN386. That's ARM test board, which was used normally for testing, for many other and debugging, but apparently there was no support. So we did support. We did make a support of Huawei and Shin did this kind of work. And I was discussing yesterday with Kaspar about simplifying the board support, and yeah, I hope there will be some improvement in future with that. There is also another project which is Bluetooth match simulation, also which would include both RIOT and OpenHarmony. And along with Huawei and Shin, Yuchang and Zhihao are here also on this project. They also made an app for the phone to support all this. So, what was the strategy to port RIOT on OpenHarmony, or what is the current strategy? So basically, to boot RIOT on RIOT OS on target hardware, we have several boards which we use RIOT OS, but one board which is used for debugging currently is QEMU board. Also, a compatibility layer between Harmony OS and RIOT SCAL needs to be created. It was still in the process of making it. So, and to kind of link everything together, this also presents a challenge because the build systems are currently different. So, and yeah, once all this is done, then I guess build will be possible, and for the devices to work, so HDF drivers which will also be needed to be added to RAM. Yeah, so there's a lot of work. Currently, we are, I think, somewhere between phases 2 and 3. I think Diman can confirm that. Right? So porting RIOT OS to QEMU was done already. So basically, we needed to actually be able to debug what we are doing. So yeah, that was a success, and now we come to the project which we will demo here today. But this is the project which would simulate Bluetooth mesh network. We did it on the feather sense boards, and which will connect and create a mesh between themselves automatically, and then made 60 or made 60 phone would connect to one of them and display the mesh network as a graphical representation of the network, right? And so if the demo is ready now, we could. So just to explain, that there is an app here, and of course, messages are displayed at the terminal. Fortunately, we cannot display both, but I think we could try to connect and run stuff on the just to see the screen of the on the phone, right? Okay, so boards are connected now, right? Yes. And running, and now you can connect the phone to the So this is the app.
Yeah, this is app. So this is our demo. Our demo is based on the RIOT and the OpenHarmony, and to run to the Bluetooth the multi-hop network. And the main function of this board is to communication with the multi-hop network, and also dynamic to update the routing tapes. And the function of the application in the phone is based on OpenHarmony, and to show realize this communication and realize the message how to transmit in the node graph. So here you can see we have researched some board in here, and yeah, there have 4 boards, and we connected one of these. Wait a second. So maybe they should wait some time. So I change the other board. Okay. You can see in here in the bottom, we can have the message count and also the last message. So this means we have received this message. So next we enter to the node graph. In the node graph, we will automatically based on this board and to display how they transmit this message and show moments and show how they and show which board we have devices connected. And maybe there have some problem because the board is always will change their network. when they connected. This is a dramatic the root tables update. And now you can see here I have a 4 boards. And you can see here I have the message from the device 1 has maybe sometimes pass the device 3 and to the device 4. And sometimes we will device 1 to the device 2. So this is based on the multi-hops network, how to connect it. So in the other words, you can link this board, you can show the board's information. They have the device name and MAC address and the status. And also you can delete the board or add more boards by yourself. For example, like this, you can just put your device name and the device MAC app. So this is our demo. Thank you.
Thank you. So yeah, we had a video in case the demo didn't work, but luckily it worked. Okay, so these are the messages. Okay, oops, yeah. So just one last thing I wanted to say is that there are many OpenHarmony technology and developers, technology clubs and developer associations, which can provide students to work with the latest OpenHarmony and Huawei technologies. There are more than 100 universities in China who have them, and we were thinking maybe if there is interest, maybe we could have one at TLS or somewhere else. So we have internships and working students programs. So for those who are interested, they can contact me or anyone else at the Huawei Research Center. Yeah, then that was it from us. Thank you very much.
So this time, yes.
That's it.
So great, thanks for the presentation and also the fancy demo. Any questions or suggestions to Lazar or to Huawei?
You mentioned how you integrate or you plan to integrate the RIOT into the whole OpenHarmony framework. And you managed already to get through the first few steps. But as you also said, like there are a couple of challenges. Like you probably can change your make files and or regenerate make files out of the Ninja files and so on. But some of the framework or the differences in the framework, the operating system framework, would be tricky to tackle. I wonder how you, like the driver framework, that would be a challenge, I guess. I wonder how you plan to address those.
Actually, I would like Dima to come here to answer the question, because he's actually the one who is doing it.
Yeah, so thing is, RIOT basically currently uses the makefile systems to build itself, while OpenHarmony and Harmony OS uses the GN or a Ninja. GN is basically advanced versions of the Ninja to build the system, basically. The thing we initially tried is like collecting the required files which we need for the compilation. I think some of might also read the matrix set. I asked a few questions there also for compilation. What I initially tried is like select the specific files of the RIOT kernels from sys packages and core kernel and then build the entire system. But unfortunately, it didn't work out well, and because RIOT requires some what I said definitions and C flags and all that, which cannot be defined like automatically without the make files. So what currently we are trying to integrate the RIOT completely inside the OpenHarmony is we are building a static library of the RIOT. We compile the entire RIOT using the make option only. Like we created the Python scripts which run the make command using the GN. which builds the RIOT. Then we collect the object files of the RIOT. We create the static library. And as we know, the OpenHarmony is a distributed systems. Okay, like as we see in the technical drawing, or OpenHarmony is a distributed system. So how OpenHarmony works is like it always creates the object static libraries for each of the individual subsystems of the OpenHarmony. And at the end, for any of the system, it combines all the static libraries using different functions, different approaches in the OpenHarmony. So similarly, a similar approach we are currently trying to build the RIOT as a static library and then merge it with the other static libraries which are generated by the OpenHarmony.
Thank you.
Any other questions?
So yeah,
Do we have any other questions?
I'll just like to add that the biggest challenge also that we expect is this adapting drivers to RIOT, because many of the drivers for Harmony OS are not open source. We have initially we wanted to do this with Huawei's Neolink technology, which is kind of improved version of Bluetooth at longer range and smaller latency. But the drivers were the problem. So the porting of the drivers was not possible because it's still not open source.
So you mentioned that there's already a Light OS and Light OS 8 or whatever. So how does this compare to RIOT? Why are you interested in having RIOT as another kernel? You already have Light OS now.
Well, thank you. It's a very good question. As I said, RIOT is academically renowned and used in classes. So it's something that students can be made familiar with very easier than with something like Light OS, which has to have some which has to be made really flexible for the industry. So it would enable us to have a much bigger presence at the universities, especially in Europe, namely Germany. Right? So that's the main goal for this. Other than that, many things can happen on RIOT, which can be ported later somewhere else, right? So it is an open system. Right? You can add kernels. In fact, there are also some other microkernels which are supported, like Uniproton, or now Huawei has its own home kernel and stuff like that. So adding one more, it's a good also lesson for the students, and also facing the challenges in all that. So I believe that covers all the angles.
We have further questions, maybe a quick one. Yes, sir.
Yeah, I was wondering about the firmware update solution, whether you're planning or whether you have something already on your Harmony OS side, or whether you want to, for example, reuse something from RIOT OS based on the suit itself earlier, because it's like a core component.
Yes, well, we're not there yet. So thank you. I mean, it's a good good property to think about, and I think Europa will be subject to some later projects. Thank you. Thanks for the idea.
I can send you point.
Yes, thank you.
All right, thanks for the answer and questions, and we will have to go to the next speaker then.